All right, let's do some math. Let me get the microphone right here. Okay, I think you should be able to hear this. Good. All right, so good work, Eric, on this guy here. Now let's look at this. B and C are basically the same problem. You got the answer right, but you got to be careful because it has to do with positives and negatives, obviously. So the key here is if the square root of x squared, you got to be careful because you don't, this number here will always be positive, right? Because if you take a number and you square it, it will always be positive. And so you take the square root of a positive number, that will always be, this is, you know, x squared is positive, and then the square root means the positive root. So if I take the square root of x squared, I have to say that that is equal to x, the absolute value of x. And so there's this game where you always have to be looking for the inside, and if the inside is positive, then you must make sure your final answer is positive. Okay, so there's a few flavors of this problem. So, right, so if I, let's just go back and look at this. So if I say the square root of x squared, if x is -3 here, then -3 squared equals 9, and then the square root of 9 is 3. It's not -3. So it's legal to put this -3 inside here. You square it, and then the answer needs to come out 3 because the square root of -3 squared is not -3. If I take a -3 and I square it and then I take the square root, the answer is only a +3. I don't know if this kind of makes any sense to you, but it's the way that all of these problems are going to work, where you kind of get the right answer, but you got to put it in absolute value to force your answer to be the positive root. I don't know. Let's go through a few more of these just so you get it. Okay, so if I take the square root of x to the 6th, this number is always positive. X to the, whether or not x is positive or negative, x to the 6th is always positive. The square root is always positive. So if I start with a negative x, the answer has to be positive. So I must put absolute value around the answer. Okay, maybe that, I think that explains it a little bit better. All right, I'm just going to delete that. A lot of writing for what's kind of a stupid problem, but I mean, I don't know, it's not that stupid. Okay, so here, if you can see this, so x minus 7 to the 14th is always positive, right? Because this forces the answer to be positive. Right? X squared, x to the 4th, x to the 6th, always positive. But x minus 7 to the 7th could be negative. So I need to use absolute value symbol around the answer. Same here. The 12th root of x squared, this is always positive. So the answer is kind of x, but no, got to put an absolute value. I'm beating a dead horse here, but let me go one more that's kind of a trick. So if I say the square root of x to the 4th, and then the answer to that is, right, the square root of x to the 4th is x squared. Do I need absolute value? I don't need absolute value here because x squared is always positive. So let's just make a little chart here. Let's go x to the 8th, x to the 6th, square root of x to the 4th, and the square root of x squared. Well, this one is x to the 4th. This one here is x cubed, but it's got to be absolute value because x cubed can be negative. X squared can't be negative. So it's like that. All right. The horse has been beaten dead. So we're just gonna get rid of all that. Okay. Let me know if that doesn't make sense. I can try again, maybe on the phone or something. All right. Here we go. Oh, that's the same. These are the same problems. Oh, I duplicated those by accident. Okay, whatever. All right. Here we go. Oh, okay. So this one here, you got 6 over. You understand how to. You understood really well how this was good. So you rationalize the denominator. But when you rationalize the denominator, if you have a squared term, this is right. This is 13 root. You only have to create two square roots of 13. But here you have to get an x cubed underneath. You have to get an x cubed underneath, not an x squared underneath. Because if I just take this and I go like this, I end up with the cube root of x squared, and I can't. This can't be simplified. Whoops, this should have been cube root of x. This can't be simplified. So instead, what I need to do is I need to get 3 x cubes underneath there. So I need, what is it? I have to get 3 of these. I need 3. So we take the cube root of, x squared. And now we get 6 times the cube root of x squared on top. And on the bottom, we get the cube root of x cubed, because x squared times x equals x cubed. And so now we can easily say, there's our answer. Right? Let's switch colors for fun here. All right, here, oh, you just didn't simplify enough. So this is right to here. So this is right so far. You just didn't go far enough. You need to simplify this guy here. So, right, this is equal to y to the fourth times y times x on top. And that's equal to y to the fourth times the square root of xy, which is equal to y squared times the square root of xy over x. Right, so you needed to simplify this one. Keep going. Just didn't go far enough. All right, this next one. All right, this one's a little bit tricky. So let's tackle this guy. So we have x to the minus 2/5. Well, we know that that's the same thing as 1 over x to the 2/5. Now we can't have fractions on the bottom. So I'm thinking what they want to do is this. There's a couple ways to do this, but I'm thinking they want this. So if we want to, we can rewrite that, right? You can rewrite anything x to the a over b is equal to x to the a to the root of b, right? So in this case, this is the same thing as x squared, the fifth root of that. Now we just need to go back to what we did earlier and say, well, we need to get 5 x's underneath, because we can take the fifth root of x to the 5. So what would that be? How many x's do we need? We need 3 more. So we x cubed, x to the fifth, and you got to, whoops, fifth root of x cubed times that. So now we get the fifth root of x to the 5 on the bottom, and on the top we get the fifth root of x cubed. So that's the fifth root of x cubed over x. I think that's what they want. They may have some other way of simplifying it that they want, but I think that's the way they're going to want it. That's the way I would want it as a math teacher. All right, let's switch to orange just to keep it fresh here. Oh no, okay, this next one, let's see. So we got 3 over x to the half. The thing is you just need to think about what this means, right? X to the half is the same thing as the square root of x. Okay, and if you do that, then we could just have said 3 over the square root of x minus 2. And now you got to just simplify this the way that you know how to rationalize the denominator. So that's, you need to take the not the reciprocal, they call it the reciprocal, I forget what the thing is. It's the, the thing that looks like this. I forget what that's called. Conjugate. It's called the conjugate, right? So that is equal to 3 times the square root of x plus 6. Right, 3, and then over x minus 4. Right, the whole key was that's equal to square root of x, and then things become simpler. Oh, this next one. Okay, so you need to know this rule. The rule here is the log of e to the anything is equal to the anything. So, right, so if I take the log of e squared, that's just equal to 2, right? The log of e to the 93x, that's just equal to 97x. Sorry, x. Right? Because basically the log means to undo what the e did to that thing. That's what that means. So if you take e squared, the log of that is just the exponent. The log says kind of, what is the exponent that e is raised to? Just take that thing, right? So in this case, log of e to the 3x, you just take that thing. Right? Right. I don't know if there are any other tricky versions of this. We'll probably see a few tricky versions of that down in these problems here. Okay, we're getting close. All right, good. All right. Okay, so let's just take these down one at a time. 2 log 5 of 4 to the x. So we're gonna use an interesting rule here, right? So we know, first of all, let me just tell you the rule. So the log of y times the log of x is the same thing as log of x to the y. Right? So that's the same thing as this rule here, right? The log of e to the 3x, that was an underline, that's equal to 3x times the log of e. We could have done it that way to get to the 3x. And the log of e is equal to 1. So that's another way you could have gotten to the 3x answer. Okay, so let's remember this identity here, right? So the identity is, you can just take this and stick it up there, and these are always equivalent. Okay, so in this case, we want to make, if we can make what's inside the log 5 equal on both sides, then we can just get rid of the log 5s. But we can't do that because we got this 2 sitting out over here. But we have a cool identity that'll fix the problem. So we can just take this guy and stick it up there, and then we got log 5 of two things that are the same. All right, so we're going to take this down, and we're going to say, well, log 5 of 4x squared is equal to log 5 of 256. And now it's really cool because we can just drop these log 5s and say that these two things are the same. And then we just say, well, 4x squared equals 256. Square root of 256 is 16. 4x equals 16, right? Square root of that, square root of that. So we get x equals 4. Got it? Okay. I'm going to just erase this. Delete. And we're going to go do the next one. Okay, so these next ones are all going to, I think all the next ones require calculator. So let's do the same one. So 7x squared equals 327. So the whole key here is to get things out of, you use logs to get things out of exponents. Again, using this trick here. Using the trick that I just showed you earlier, right? The trick that says log of e to the x is equal to x log e. So let's do that. So we have to take the log of both sides. So in this case, we're going to say, well, I'm going to take the log of 7x squared equals the log of 327. And you look at that and you say, well, boy, things got more complicated. I didn't have any logs. Now I have logs. But check this out. This is cool. So now I can take this guy down over here and say, well, that's the same thing as x squared log, 7 equals log of 327. And now things are getting a lot easier, right? So I can say, whoa, okay, so now I can say, well, x squared is equal to log of 327 over log of 7. And so now I can say, well, x is equal to the square root of log 327 over log of 7. And I can just, now you just got to type this thing into your calculator, right? And you go log, I'm just typing this into my calculator and I'll tell you what I get. Hopefully you get the same thing. And wait, then I gotta go. And they say carry this to 4 places. So I get x equals 1.7249. Okay, so you're going to use your calculator on all of these next and all the ones on this page except for that first one. Okay. Boom, boom, boom. Delete. All right. This next one's an inequality. This is kind of it's the same trick. All these are the same trick. So 5 to the 3x is less than 211. All right, got to get this thing out of the exponent. So we're going to do log of 5 to the 3x is less than 200. Sorry, the log 211. You know, we could be you could here use not regular logs too if you wanted to. It's all the same thing, but we just use the natural log because it's cool. But it doesn't matter. You could use log base 72 if you wanted to. But calculators are really good at doing logs in natural logs, LNs, which is basically log base E. All right, so now we go 211. Keep that side the same, and this side is 3x. Remember this whole trick about dropping this here. You can just move it back and forth up into the exponent or out in front of the natural log, and those are equivalents. So now we say, okay, well, 3x is less than log of 211 log of 5, and now x is less than log of 211 over log 5, 3 log 5, because we're going to multiply both sides by a third, right? So x is less than, let's see, let's type this in. Hopefully this is where I sometimes falter. Divided by 3 times log 5. And it says it wants it to 4 decimal. It's nice when they tell you it's 4 decimal places, then you know that it's going to be a tricky answer and that you're probably using your calculator. 1084. That's what I get. All right. Delete. All right, solve the equation here. All right, this is the same trick one more time. All right, we're just gonna, it's all just, this is back to mostly algebra and then just using the one trick that you need to know. And that is the whole moving, simplifying and then taking the log and then moving the exponent down, right? The whole key is algebra using the natural log, to get rid of the exponent and then more algebra. That's everything we're doing. All right, so we're going to add 9 to both sides. 84 for e x to the minus 1 equals that. Divide both sides by 4. That's 21. So we get e x to the minus 1 equals 21. Okay, we're going to take the log of both sides. So that's x minus 1 times the log of e. The log of e is equal to 1. So x minus 1 equals the log of 21. So x equals the log of 21 minus 1. So the log of 21 minus 1 is equal to x. It says 4 decimal places, 2.0445. All right, there we go. And this last one's the same. Delete. Oh, undo. All right, boom. All right, let's go back to purple maybe. So now we've got 2 log 3 plus log 3x equals 6. Well, this we can calculate. Let's wait to do that calculation. Okay, so we get log of 3x equals 6 minus 2 log 3. Okay, we want to get rid of this thing. So the way that you get rid of this is it's kind of like we're going to go in the other direction. So the log of 3x, I can go, if I go e to the natural log of 3x, that's equal to 3x. So just write the log of e, if I take a log of e to the something, that's equal to x. I can also just go e to the natural log of something, and that also equals something. These are just kind of inverse operations, right? And you can do them. The log of e to the something is the same thing as that thing, or e to the log. So it's just kind of the opposite thing, the opposite truth that we learned earlier. So let's see how that applies here, right? So if I just raise both sides to the e, that'll help me out. So if I go e to the log of 3x, and I raise this side e to the 6 minus 2 log 3, then on this side I get 3x equals e to the 6 minus 2 log 3, and then I'm going to divide both sides by 3. So that's equal to x. So this is my answer, and then I have to calculate that out. So I'm going to type this in, and I'm going to say, well, second, e to the parentheses 6 minus 2 times log of 3 divided by 3, and I get wants 4 decimal places. So I get 14.9418. Hopefully that made sense, right? So again, if I ever see something, if I ever see log of, x squared, and I want to get rid of that log, and that equals 4, what I need to do is I need to take both sides e to that, and then I can say, well, these kind of cancel. They don't cancel. They're inverse operations. Equals e to the 4. Oh, cool. Then I can say, well, x equals e squared. So x is equal to e squared. Okay. Cool. All right, last one. So you just got the formula wrong, right? So on this one, y equals a e to the 0.24 t. So y is equal to the final population. A is equal to the initial population, and t is the time. And this here number is the growth constant. And that's going to be different. And so they just tell you that the growth constant here is 0.024. So we just got to do the formula differently. So you say, well, y, the final population, because they want to find out what it will be in 7 years. So the final population is what we need to find. The starting population is 800,000. E to the point 024 times 7. So y is equal to, if I type all this in, I got to say 800,000 times e to the 0.024 times 7, and I get 946,349, and that's rounded people. All right, it's a wrap. Hopefully that helps. If one of these doesn't make sense, let me know, and I will see what I can do to explain it better. That first one, I think I spent more time than anything else trying to explain all this square root stuff. But I really think that the answer is, if you kind of think about these ones, x to the 8th, square root of x to the 6th, square root of x fourth, and square root of x squared. And this is x to the 4th, and this is the absolute value of x cubed. This is x squared, and this is the absolute value of x. Because this is always positive, this is always positive, but this here can be negative. So, but square roots the square root means only the positive value. So that's why you have to put those inside absolute values. Okay.